All right, good morning, afternoon, whatever we are. How's everybody doing today? All right, good morning. How's everybody doing today? Cool. Awesome. All right, any questions up front? Any lingering issues with getting into the Linux server? It looks like almost everybody succeeded in doing homework 1, which means you can get into the system. All right, cool. All right, let's talk about some logistics about working in Linux. So I'm going to hop over to the server, and we've talked about a few commands. We talked about pwd, which says show me my current working directory, cd, which says change my current working directory, and ls, which says show me what's inside my current working directory. So your directory is just like a folder. Okay, when you first log in, you're sitting in a directory which is usually /home/ your username, and ls will show you what's in that directory. Now I have a few folders in here right now, and you know, I try to organize stuff by topic, right? So I teach 3 courses: 222, 223, 224 programming courses, and also discrete structures. There's a lot of files that go along with teaching these courses. Let me hop over to my main server. So this is the main one I use, and there's a lot of stuff in here, right? Now some of this is nicely organized, like all my 222 stuff is under this folder called 222. But I also have, you know, all of this other stuff in here that, you know, I needed to do a quick program, pa1.c, and I started editing it in here. And here's something called parse.c, and over time, your file system organization can get really muddled, right? And you start having a hard time finding things and organizing things, or worse, you start accidentally deleting things or changing things that you don't mean to because things are disorganized. So here's a suggestion, and I suggest this for the server and also for your own Linux system that you're working on your laptop or desktop, whether that's, you know, native Linux or something running in VirtualBox. Think about how you want to organize your work. Your work is basically going to be a bunch of files. Source code, documentation, notes, tools, utilities, they're all files. And you want to put those in some way that you can keep track of and find things and not have them sort of cluttering up your view. So if I was starting CSE224, I might make a folder called CSE224. So mkdir, that's how you make a directory. Okay, that creates something that you can cd into. And most things in Unix, you have an option. I could have said make dir /home /nix/CSE224, right? But I really wanted that directory to be contained in my current directory, right? Sitting directly underneath where I am right now. I just wanted this CSE224. So I just said make dir CSE224. It means make this directory in my current directory, wherever I happen to be. In this case, my login directory /home/nic. All right, so I have all of this stuff, very cluttered, very difficult to look at. If I just change into my CSE224 directory, I got a clean slate, right? Nothing here clouding my view, and I can start working on, you know, my first homework2.c. And now I've got one file in my directory. Well, that's great, but then, you know, I'm going to work on homework3.c, and I'm going to put some stuff in there, and maybe homework3.c needs me to write a function called function.c, and then I'm going to make a readme. Right? And now suddenly I'm in my CSE224 folder, and I've got a bunch of stuff in there. And I got some stuff from homework 2 and some from homework 3 and a readme that I don't know what that goes to and so on. So organize this, right? Make yourself a directory called homework 2. Make yourself a directory called homework 3. All right. If I've already made files and I want to move them into another directory, I can use the move command, mv. So I could say move homework2.c into this directory called homework2. I could say move homework3.c into this homework3. I could move function.c into homework3. And my readme, let's say that went with homework3. Alright, so now I'm in my CSE224 folder, and what do I see? I see two subfolders. One for the second homework, one for the third homework. Nice and clean, right? I'm ready to work on homework 3. There's the files associated with it. I don't have homework2.c cluttering this up, and so on and so forth. So it's nothing all that startling, right? But this will help you a lot. Okay? I've had so many students come to me in the past and they've lost their work, right? Or they thought they were making changes to one program and they were accidentally making them to another, and all their changes don't seem to have had any effect. And by the time they figure it out, they find out they've wrecked another program that was working and they just changed it, and it gets to be a real nightmare, right? So come up with some kind of organization system that works for you. You can change it over time, right? Maybe I decide I want all of my homeworks to go in a separate area. So in my home directory, I could make a folder called homeworks. And I could say move homework 2 and homework 3 into homeworks. And I could have another program, another folder called programs, and now I've got, you know, two main categories. And if I go into my homeworks folder, I've got my homework folders. And if I go into one of those, I've got the stuff associated with that. And yes, you can use MV to move a directory or a file. So if I wanted to change the name of this file, homework 2, I could move this to, you know, second homework.c. And so I just renamed my .c program. If you move a file into a directory, it moves it. If you move a directory into something else, it'll rename the directory. And like all things Linux, you know, there's manual pages for the mv command, and it's got a fair amount of options. If you're unsure about move, you can also use copy. That's just cp. Copy leaves the original file intact, but makes a copy of it somewhere. And also has lots of options. All right, let's talk about sftp. sftp is a nice little utility. It's been around forever. And it's designed to let you copy files from one system to another. Okay, so you've got your own Linux system running on your home machine. And that may be where you want to do most of your development, so that you don't need an internet connection, you don't need to deal with, you know, slowdowns in the Linux server, possibly getting disconnected. You're probably going to do a lot of your development on your own system. But then at some point, you know, you want to move files from there to the Linux server, or maybe from the Linux server back to your system. All right, there are a million ways to do this. Not really a million, but probably like, 10 or 12. Different ways to do this. If you're on Windows, you can use something called WinSCP. It's a drag and drop interface, very convenient to use. If you're very command or WinSCP, yeah. If you're very command line focused, you can use SCP. You can use SSH and put copy commands at the end and so on. FTP or SFTP is a really nice utility. It's sort of a middle ground between those. And it works like this. So let's say I'm on my home directory, my home system, and I have a folder called CSE224. And let's say it's empty. And I want to copy stuff from my Linux server account. Okay, so SFTP and the string that you would use with SSH. So username at server, I'm going to go with Nick at linuxengrcs.com. Now normally when you do this, it'll ask you for a password, just like SSH. You type in your password, you don't see anything, you hit enter, it logs you in. I've got automatic login set up. So once you're connected, you can do a subset of Linux commands on the remote machine just by typing them here. For example, I can say pwd, and it'll tell me I'm in /home/Nick. That's on the remote machine. I can say ls, and it shows me everything that's on that remote machine in that directory. This is the directory we just looked at, right? There's my CSE224. Linux is case sensitive. Everything is uppercase, lowercase, distinct, and that can make it interesting looking at things in alphabetical order sometimes, because uppercase letters come before lowercase letters. You may have noticed CTC Link does this also when you look for computer science. Things with uppercase letters come before the lowercase ones. Anyway, so I can say, let's change into CSE224 and show me my directory, right? My remote directory is home Nick, CSE224. List the files in there. Well, there's, the directories that I just set up a few minutes ago. And I can say, let's go into Homeworks. And let's go into Homework 3. And, oh yeah, I wanted the contents of that README file. Okay, if I want to copy that README file over, I can do the following, get README. And it'll say it's fetching this big long path to the file, right? And it's copying it to something just called README. This is a progress bar. It's accurate, unlike, a lot of progress bars. It should tell you how much of the file has been transferred, so it should track pretty closely. Number of bytes transferred, transfer speed, transfer time. It's more interesting for big files. This has copied this file README into my current directory. I can get out of here with a Control D, and now if I look, there's my README. Now I can make changes to that file. So cat is a way to look at the contents of a file without editing. So there's my file right now. It's got a bunch of lines in it. I can SFTP back to the server, go back into CSE224, Homeworks, go into Homework 3. I can say put README, and it'll push that file from my local machine to the remote machine, uploading README to this directory. And now if I go back into the server, and I cat my README, it's my new file. So it's a simple way to move things back and forth. It does a lot. It lets you do commands on the remote machine. It also lets you do commands on the local machine. Like I can say LLS for local LS, LCD to change my local current directory, and so on. You can check out the man page for it. It's got a lot of options, but then it's also got a section that describes what you can do inside SFTP. So changing directories, changing permissions on files, getting files, changing your local directory, and so on and so forth. Play around with it. It's useful. It's always available. It works no matter what your underlying system is. If you find yourself on a Mac and you don't have WinSCP, how do you move files around? You can always go to sftp. You can do this from your phone. And you can do it Unix to Unix. All right, so I'm using a few tricks when I do things on here, and let's talk about some of this. So let's go into homework 3. All right, so I have 3 files here: function.c, homework3.c, readme.c. Let's say I want to edit function.c. Right, that's a lot to type. function.c. Easy to make typos, you know, and if I accidentally make a typo, I start editing a new file and I WQ that, and now I've got more files sitting in my directory and so on and so forth. So shortcut possibilities. If I start typing the name of a file that I want to do something with and I hit a tab, the shell will complete my file name for me. Okay, so tab completion, really powerful, great speed saver, time saver, great way to eliminate typos. Just hit a tab. And it will complete as much of your file name as it can. But if there's ambiguity, for example, if I say vi fun and I hit a tab, it doesn't know if I mean function, function2, or function3. So it will fill in as much of the name as it could, and then it stops. And now if I hit 2 tabs, it will show me all the possibilities. Right? Everything that matches what's been typed so far. So it could be any of these 3 things. And if I meant function2, I can type the number 2. And now if I hit a tab, there's no ambiguity. If I want to edit a function that starts with function2, the only possibility in my existing files is function2.c. If I just say vi and I hit a tab twice, it shows me everything that I might possibly want to edit. So that's kind of cool. And if I type the first letter and then just hit a tab, it'll complete it as much as possible without being ambiguous. So tab completion is one of these things that, like, you have to remember to use it, but once you've used it a few times, you'll probably stick to it. Right? You'll find it's just saving you a lot of time. And you want your file names to be as descriptive as possible. You don't want to call your files something short so you don't have to type them in. Right? Function is not a really good name for a function, right? What function is it? I don't know. So I'd rather have something called, timekeeping function.c, right? And every time I want to edit it, I can just say vi, put in the first part of time, and hit a tab, and it'll fill it in for me. And it's not just vi, right? I could do GCC, type in the first few letters, and hit a tab, and it'll complete that for me. All right, so tabs are useful. And by the way, when you run a program, you're basically asking for a file. So if I type in a G, C, and I hit a tab, well, it doesn't fill in anything. It tells me there's some ambiguity. If I hit a second tab, I see all the commands that start with GC. So if I type GCON, it'll fill in GCONF, gconfigure, and if I hit 2 tabs, it'll show me all the things that that I might have been planning to type. And so I can type tool and hit a tab, and there we go. So what happens if I'm sitting at the command line and I just hit 2 tabs? It says there's 1,878 things I might have been planning to type. Do I want to see them all? So this is one case where Linux warns you that you're about to do something kind of extreme. So I can say yes, and it shows me all the things I might have been planning to type. And there's almost 2,000 of them. Alright, so tab and tab are useful. This is for completion. This is for looking at the possibilities for completion. Another thing that's useful is using your up arrow and down arrow. So my prompt on my system is usually a number surrounded by some kind of delimiter. I use curly brackets when I'm on the server at school. I use square brackets for my own machine at home, just to help me keep them straight, right? It turns out that Bash will keep a history of all of the commands that you've executed. And if I want to go back to a previous command, I can hit my up arrow, and I can work backwards in time through to my previous commands. And I can hit a down arrow to go forward. And at some point, you know, I can re-execute a command by just hitting enter. And if I want to see all the commands I've ever typed, I can use the word history, and it shows me my full history. In my case, it only keeps 5,000 commands. So I've typed 20 new commands so far today. But this is useful. This is really useful sometimes, you know, you did something a few days ago and your file is gone and you think you moved it somewhere weird, right? You could go back through your history and you might find where you did that. And you might be able to figure out where your file went based on that. Or you had some really cool command that you used and you can't remember what it was, right? Go through your history. Another thing I can do is I can use 2 exclamation marks to repeat my previous command. So my previous command was history. If I just say exclamation mark, it repeats that command. And now you can see I've done history twice. If I want to repeat a command that started with something like my last GCC, I can say exclamation mark GCC, and it'll repeat my last GCC command. I can also use exclamation mark $ to pull back the last word on my previous command, or exclamation mark asterisk to pull back everything except the first word on my previous command. Okay, what does this mean? My previous command was to try to GCC timekeeping function .c. If I say vi exclamation mark $, that will pull back my previous command, but it will replace everything except the last word in that command with vi. This is a shorthand way of saying vi, that last file that I just tried to compile. So now I can come in here, I can comment that out. And now if I want to recompile it, I can just up arrow twice, recompile. Oh, I didn't have a main program. Up arrow twice, I'm back to my vi command. Let's write a main program. Up arrow twice, there's my GCC command. Now I can compile again. If I want to make some changes, I can up arrow twice, edit it again. Alright, so why am I telling you these things? You don't need to go off and memorize these. You don't need to force yourself to use these. But I want you to know that things like this exist. And these are a few of the tricks that I've found useful over the years. But there are zillions of these things throughout the system, right? And you can make up your own. What you want to do is leave yourself open to trying new things, right? If you find yourself constantly saying vi timekeeping function .c. Oh, I made a typo. vi time keeping. Oh, I made another typo. vi time keeping function.c. I can't even remember what I was planning to do once I got in the editor now, right? So I'm being silly about this, but you know, put yourself in the 2 a.m. mindset. You've been coding for the past 8 hours, and you got another 4 hours to go before you're finished, and you're going to turn in your project. You don't want to be doing this stuff, okay? You don't want to be spending your brain cycles trying to spell your function name or remember the command that you used to compile a program or something like that. These are things that will save your brain cycles. Okay, they let you concentrate on what your task is at hand. For example, writing your program, getting your program to work, merging your program with somebody else's program, right? So keep these things in the back of your mind, jot them down somewhere, put them on a post-it note or something, and you know, at some point you're in this situation where you've got a long function name and you keep having to type this out. How did we learn to do that, you know? Oh yeah, I can just say, you know, exclamation mark vi, and it'll repeat my last vi command. Or I can just up arrow. So things like that. All right, questions so far? Someone said only 5,000 commands. Yeah, but you can make it longer too. It's kind of interesting sometimes to go back and see what you were doing, like, you know, a month ago, what commands you were repeating again and again and again versus today. All right, let's go on. So we're gonna start talking in a few days about shell scripting, and basically, I'm editing my file and I want to compile it and I want to execute it, right? I can make something like a script called Go, and I can say gcc-o time and then let's go ahead and execute it. And we'll talk about these commands I'm typing. But right now, go is a command that if I just say go, it will do this. And then it will do this. So if I say go, it compiles and executes my function. Now if I change my function, like that, and I say go, it compiles it and it executes it. So if you find there's, you know, 5 or 6 things you keep doing in a row, you can throw them into, in Windows it would be called a batch file, right? But it's a shell script. It's a way to bundle a bunch of commands together. You can also make things called aliases. Right, so what I'm doing here is I'm setting up the symbol C to be a shortcut for all of this, gcc-o timekeeping function.c. And now if I just type C, it acts as if I typed in all of this stuff.
Is one method better than the other?
Totally personal taste. I mean, you can do a lot more with a shell script. And most of what I do in my life now on Linux is running shell scripts. For example, I have a script called on-screen display that lets me say on-screen display for school. This is a test, and it lets me put a pop-up up here in the corner. that's what's happening when I'm time-stamping the video. Is I type in a label, I have a script running that records how far we are in the video, and it also displays that message, that label up here for a few seconds. And OSD is just a script. So we'll talk a lot about shell scripting. It's going to be the main programming we do in this course, is writing bash scripts. And you can get extremely sophisticated in bash scripting. And it's a lot of fun. It's like quick reward for not a lot of effort sometimes. By the way, you can also set up symbols. So I have a symbol called Linux, which is equal to nick@linux.engrcs.com. So when I SSH into $Linux, it's doing SSH nick@engrcs.com. Just another shortcut. All right. Is that a question or comment?
Just saying thank you.
Okay, welcome. All right, here's another thing we can do. Particularly if you're running on your own machine and you're doing development. Let's say I'm sitting right here. So I'm going to write a main program. So I'm going to compile my program. Well, I got all kinds of errors in my program, so I have to remember what the errors are and then go back in and edit my program again. Okay, here's another option. Make yourself multiple windows. Okay, so I'm using a terminal program called Console. Different versions of desktop managers have different programs available, but most of these terminal programs, they support tabs. So I can actually just hit a Control-T to open up a new tab, and I'll be in the same directory I was already in, and so I can do my compilation in this window, and I can just use a shift arrow key to go back to the first window, and there's my editor. So I can look at my messages and it says, return type defaults to int. Oh yeah, I forgot to say integer main. Okay, I'll go ahead and put that in, come back over here, redo my compilation. Implicit declaration of printf. Oh yeah, I forgot to include standard IO. Okay, I'll come back over here, I'll put that in. I'll save that, come over here, recompile. Hey, it compiled, right? Now, it's not going to, you know, prematurely age me if I have to keep going in and out of VI, but it's a little easier to just switch over here. I've already got my code up. I know where I made my last change. If I don't want to make that change, I can just undo it, right? And then I can come over here and I can just up arrow to my last command, and now I can go ahead and run my code. Okay, well it printed hello, but then it printed my new prompt on the same line. What's up with that? Well, I forgot to put my new line in. So I can hop in here and add the new line, come back here and compile, come back here and run. Okay, that's a very, very rapid development cycle. And that's what you want when you're deep in trying to work on some of your code, you know, the stuff we'll be doing in 222, 223 especially. Spend your time and energy and focus writing code, finding bugs, not, you know, going back and repeating, typing in commands and going into the editor and finding where you were and so on and so forth. If I needed to do something different, I come back here, my cursor is right at the spot where I made the last change, right? If I need to do something different, I can do it right there. Oh, I was supposed to say hello there. Okay, I'll make that change, come over here, compile, come over here, run, I'm done. Now the Linux server will restrict how many sessions you can have at a time. It's either 5 or 9 or something like that. But I think if everybody in the class opens up 9 windows to the server, it's going to slow the server down significantly. But if you're doing this on your own system, right, I mean there's not really a practical limit. You can have tons of tabs open and, you know, the load on my system is pretty minimal. Not taking too much time. This high CPU load is actually something else that's running in the background, which we'll talk about another day. All right, let's talk about GCC, which we've been using. So let's talk about this whole compilation business. So we're writing a program, hello.c. Okay, this is what we call source code. This is the human readable stuff. The stuff that, if you're a human who knows C programming, you know what this means. Oh, I think I lost it. Main. All right. So there's my hello.c. This is stuff that, you know, presumably we understand, right? The CPU, the actual hardware inside my processor, has no idea what to do with this. It can open it up in an editor, it can display it on my window, but if I say execute this, it has no idea what to do, right? It means nothing to it, because the CPU speaks a very different language, okay? Engineering 270, it speaks machine language, ones and zeros. So before I can execute this program, it has to go through some kind of translation into what's called machine code. Bunch of ones and zeros. All right, so how do we compile? Well, one way to compile is just gcc hello.c. And when you do that, you get a file called a.out. That's your executable program. So the process here is gcc, and it creates an a.out, and if I type in the name of that file, a.out, it runs. And if I change hello.c and I recompile it and I re-execute a.out, it runs my new program. If I try to edit a.out, I don't have a lot of success. This is binary code. This is stuff that is meaningful to the CPU. Now it has some human readable stuff. It's got ELF. It's got LD Linux x86 64. It's got libc start main. But mostly this is stuff that means something to the CPU and not a whole lot to me. And if I make changes to this, right, I'm probably going to break my file. Not a really bad thing because I can always recompile. Right, but this is really meant for machine consumption, not for us. If you want to look at it more nicely, you can use something like XXD, and this will show you the contents of the file in hexadecimal, so base 16. And if something happens to be human readable, it'll show it to you over here. But a lot of times, if you just sort of type out the contents of an executable file, you mess up your display. You get weird things coming out. And sometimes it leaves your screen reverse videoed or things like that. Alright, so this compilation actually takes multiple steps. Your hello.c gets actually changed into something called an object file. And that actually gets changed into something called assembly language, which is usually a .s file, and that gets assembled into an executable file. But when you say GCC, all this stuff happens, and you're left with the executable. We'll talk about these individual steps later when we talk about make files, because sometimes we only want to go down to an object and we want to do something else before we make an executable. All right, so this is great, except that every time I say GCC anything, my executable is called a.out. All right, so what can we do about that? Well, we can put a switch on GCC. So when we say GCC, we can say GCC-O. And we can put in the name of an output file, and then we can put in the name of the thing we want to compile. So for example, GCC-O hello.c. And you can edit your line by using left and right arrow keys, by the way. You can go back and fix typos. You can also use control arrow keys to move through your line more quickly. It moves you a word at a time. So GCC-O hello.c, and that makes an executable program called hello. And if I run that program, it executes my code. So I don't need my a.out. And if I make a new program, hello2.c, I can compile that, and now I have two executable programs, hello and hello2. Hello is still my original program, hello2 is my new one. So it's really inconvenient if every time you make a new executable program it's got the same name, right? Because you end up clobbering your old programs. So you can use this -O switch to say I want my output file to be called whatever I specify here. And it can be anything you want, right? I could have called my executable for hello2 goodbye, right? And now if I say goodbye, it says goodbye. And I have two executable programs that both run the executable version of hello2.c. All right, this command can be a little treacherous. You can get into trouble with this. So for example, here's the most common mistake, okay? So here's a really common mistake with GCC. GCC-O hello.c hello. What am I doing wrong here? I just switched the order of these two arguments, right? I try that, I get errors. Oh yeah, I made a mistake. This should have been hello.c. This should have been hello. Alright, what the heck just happened? I just lost my hello.c. It's gone. What happened was when I said this, I asked the compiler to compile hello, which was an executable program, and to put the output of that into hello.c. While it tried to compile this executable program, it found out that it couldn't do that because it wasn't C code. And so instead of producing an output file, right, it got rid of my output target hello.c, and hello.c is gone. And then down here, when I tried to compile hello.c correctly, it told me hello.c, no such file or directory. And that's when you hope that you're doing something as far as backups. Because that easily, my hello.c is gone. And if that's 5,000 lines of C code I've been working on for 2 weeks, it's gone. No getting it back, right? You'd have to pull the hard drive and do some hacking on it and try to reverse the deletion that just happened, and it's not gonna be doable. So Linux will do exactly what you want, which can be really nice, but it can come back and bite you. Okay, so we're going to talk about Git. Git is one way to deal with this. It's a way to keep backups in place as you're working, and hopefully avoid this kind of mishap. An easy way also is just, make yourself a backup directory, and every now and then copy everything .c into your backup directory. Now if I accidentally remove hello2.c, it's gone. Guess what? I have a copy in this other directory from whenever the last time was that I thought to push it into there. So you can do little things like that. I have before I started using Git, I have a little thing where if I have a directory named uppercase backup, I can just say backup, and it will copy all my stuff into a subfolder of backup marked with the date and time that has all the stuff in my current directory. So anytime I'm at a point where I'm feeling kind of fidgety, like, this is a really good piece of progress I made, I just say backup, and it makes a new subfolder, right? And backup is just a command, right? It's just an alias to all of this stuff. Figure out the date, make a directory with that name, copy everything into that directory. Nothing magic there, right? But the kinds of things that you can do with being in a Linux environment. Well, we're going to talk about something called Git. Possibly the end of this week, definitely by next week. We'll talk about Git. And Git is a proper way to maintain backups. It not only keeps track of older versions of your files, it gives you a way to get back to them easily. It gives you a way to temporarily switch what you're doing and start working in kind of a parallel universe, something called a branch. And say, okay, I want you to remember my directory exactly as it is now, but I want to start working in a parallel universe. And you can move to a parallel universe and make changes, delete things, add things, test things out, and so on. And at any point, go back to your original universe. And all your files will look like they did before you branched off. And it also lets you tie in with online services like GitLab, and take everything that you've been doing and push it off into the cloud. And you can get free, effectively unlimited storage for projects at GitLab. And so we'll talk about how to do that too. So anyway, that's probably enough for today. No new homeworks for a few days. I'll post some more stuff later on, probably next week. We'll start looking at our first long-term programming assignment, like a 1 or 2 week project. But for now, just spend some more time in the environment, mess around with it. If you haven't got Linux set up at home, go ahead and do that. VirtualBox or whatever system you prefer. Let me know if you run into problems. Otherwise, I will see you next time. All right, thanks.